All right, here we are with the last SAT question for 2024. Let's take a look. We have a system of equations. Y is equal to negative 1.5. Y is equal to x squared plus 8x plus a. So you got a line, you've got a parabola. In the given system of equations, a is a positive constant. The system has exactly one distinct real solution. What is the value of a? And it's one of those no answer choice. We've got to fill in our own answer choice, some numerical answer. Speaking of, here are some of the things that you guys put. There is one front runner here, which was, you can see that it's at 14.5 right there, with 83 of us saying it, 62.4%. It's not bad. We've done better, but it's not bad. Second place here, this thing that says 18, I think that is somebody saying that it is 16. 16 is important, but it's not the correct answer. And you'll see 16 come up whenever we go to solve this. How did we think this one rated? Well, we said this one was definitely right there in the middle, just slightly skewed towards being a little bit harder. Okay, let's take a look at the solution. And I am going to do the solution in a whole bunch of different ways. I would say the fastest, easiest way to do this one is Desmos, and that's what we're going to look at. So we have ourselves a line and we have ourselves a parabola of some kind. So this guy, right? And I do know that this thing is opening upwards because it's a positive thing. And then we have ourselves a line, and we want to have only one real solution. Distinct means different. So, I mean, if it's one, it's one. It's different from anything else. Oh, I want this thing. Okay, anyway. So let's say in order for this thing to have one solution, what it has to do, it has to hit exactly right there on the vertex. Because anywhere else, it's either going to have two solutions, two distinct solutions, or it's going to have none of them at all, right? So I need this thing to hit exactly at the vertex. All right, so what I will do is I will just go ahead and throw these two things into Desmos, and I'm going to make this thing happen with a little slider for my A value. And let's take a look. Show Desmos. And we'll start off with our line here. So just y is equal to a negative 1.5. And yeah, I don't know what's going on there. Oh, it wants me to do a slider, but ignore that slider. I think that allows you to change the negative 1.5, but we want it to stay that. All right, and then the other equation was y is equal to an x squared plus 8x and then plus a. We'll have to go over here to the alphabet there and definitely add a slider to this. And we can see right now, as this thing sits, when a is equal to 1, yeah, you've got yourself a parabola which touches the line two places. That's not what we want. So we're going to move this thing so that we can hit it at exactly the, oh man, this thing is apparently the A value has to be bigger than 10, so I can move this up a little bit. All right, so all you got to do is tap on the number there. And actually, I'm going to go to this the inequality there, and make this thing go up to 16. Remember, there were some people that typed in a 16 for their answer. And then I'm also going to do a step size of just a half. And you'll see why in just a second. All right, and then I'm going to hit enter. All right, now let's move this little slider towards the 16. Oh, see if it's 16, it actually is above our line here. It doesn't intersect at all, so I need to decrease this just a little bit. 15 is getting close. Oh, there it is at exact. Let me try that again. Oh, okay, there we go. At exactly 14.5, the line hits our parabola at exactly 1 point at its little vertex point. So there's our answer, 14.5. So A is equal to 14.5. That makes the parabola touch the line at exactly 1 point, and we would be done. Except for I want to show you a couple of different ways to do this, because often what students wonder is like, could you do this thing without Desmos? Could you do this thing by hand? Can you do it algebraically? And the answer to that question is absolutely. There's two other ways you can do it. The first one has to do with the discriminant. And the discriminant is part of the quadratic formula. If you remember, the quadratic formula looks like this. It is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Anyway, so the discriminant part of this is the thing that is underneath the square root, and depending on the value of that discriminant, it tells us whether we have one solution like this, two solutions if this line hit it at two different places, or zero solutions if it didn't touch it at all, just based on the value of the square root. And the reason why that happens is because if this thing is a positive number, if this thing is greater than zero, so b squared minus 4ac is greater than zero, then we are adding and subtracting some positive square root number. That would be, again, if I move this thing over here, it would be like this answer and then this answer. Adding and subtracting some positive square root. And then if b squared minus 4ac is less than zero, now you've got a problem because you got a negative number underneath the square root. Negative number is not a real, and it did say that we wanted real solutions. And you'll see in Algebra 2, of course, that you're going to extend your kind of perspective on numbers, and we're going to call that thing an imaginary. But when that happens, when you have that negative square root, these things don't touch each other at all. You have no solution. The one that we are concerned about, though, is when b squared minus 4ac is exactly equal to zero, because when it's exactly equal to zero, you're adding and subtracting nothing, which leaves you with one solution, because it'll just be a negative b over 2a, and this part will be gone. The whole square root is gone. And this is what we want to happen in order to make our one solution happen. So now what I'm going to do is I'm going to set my equations equal to each other by substitution, because that's one of the ways that you can solve a system of equations. I'm just going to put negative 1.5 in for y is equal to x squared plus 8x plus a. And I'm going to add the 1.5 over because you always have to have these quadratics equal to 0. 8x plus a, and then plus 1.5. Okay, so in order to use the quadratic formula, your quadratic equation has to look like this. Ax squared plus bx plus c equals 0. And now this a here is not the same thing as this a there. That's just kind of an unfortunate coincidence. So the a value, of course, is the coefficient of our x squared. So our a value for this problem is 1. The b value is the coefficient of the linear term, the x term, which is 8 for us. So b is equal to 8. And then finally, your c value is everything that's left over. It should be some sort of constant. And it's not just the 1.5. It's a plus 1.5 is our c value. So our c is equal to a plus 1.5. Now what we'll do is we're going to force this thing right here to happen. We're going to take b squared minus 4ac and we're going to set it equal to 0 and solve it for the a, essentially. Okay, so this is going to look like b squared, so 8 squared minus 4 times our a value, which is 1, times our c value, which is a plus 1.5. All this should be equal to 0, and we're just going to solve this thing for a. And I'm wondering what we're going to get. Anyway, just cleaning this up just a little bit, I get a 64 here. The 1 times 4 doesn't do much, so minus 4 parentheses, a plus 1.5 equals 0. Now you can distribute this negative 4 through the parentheses, but I'm not gonna. You'll see why in a minute. I'm going to add this whole thing. I'm just going to take this whole quantity, just add it over here to the other side to make it positive. 64 is equal to 4 times a plus 1.5 equals 0. What? No, it doesn't. I just added it to the other side. Anyway, I'm going to get rid of, instead of distributing this 4 through there, I'm just going to divide it over to the other side of the equation. That's going to resolve the parentheses. So 64 divided by 4 is 16 equals a plus 1.5. Hey, look, it's the 16 again, which is not the answer. However, I'm going to subtract the 1.5 over, and when I do, I get my 14.5 is equal to a. So there you have it. There is another way to do this algebraically in order to get the value of a. Okay. However, there's one more method, and that second method has to do with completing the square, which we have seen in another one of these SAT kind of videos. Completing the square. Now I'm going to steal this equation right here again. This one, after we have set, let me duplicate that. After we set the equations equal to each other, and I subtracted the 1.5, or actually added the 1.5 over to the other side of the equation. So here's the quadratic that I am trying to solve. So what I'm going to do, what I'm going to suggest that we do is that we ignore this a plus 1.5. Just bear with me for a second. And let's say that the only part of this that we focus on is this bit. So 0 is equal to x squared plus 8x. And then we're going to add something to this in order to complete the square. So I did this thing visually in that other video, and I'm just going to kind of duplicate that process. Completing the square, I mean, it's geometric. So we can think of x squared. It's like an algebra tiles kind of thing. This is an x by x, which makes the area of this thing x squared. And then I have this 8x for the middle term, which is going to be an x high, but its width here is going to be, did I say x high? I hope so. Anyway, so it's x high, but its width here is going to be 8. And what I'm going to do is I'm going to split this thing like right down the middle. I'm going to take half of that guy. Take my little eraser, just kind of split this thing right in half. Kind of separate these halves like this. Right, and then let me fill in my little rectangles. Okay, so it used to be 8 long, and the height here was x, but now I split it in half, so each one of these things is 4x, and this one here is a 4x. Let me get rid of this, and get rid of this. Okay, so now what I'm going to do is I'm just going to take this other rectangle here, I'm going to rotate it 90 degrees, and I'm going to put it on top of the x squared. And the reason why it fits perfectly, again, is because this height here was x, which is the same height as this one. And it leaves me a little gap here, which I'm going to complete. It makes it so that I can complete the square. I've got to put a little square right here. I just got to find out what that area is going to be. So remember that this is a 4 here, and this is an x. This is a 4 here, and this is an x. And now whenever I look, this 4 is the same length as this 4, which is the same length as this 4, so it's a 4 there. And then likewise, this is 4, this is 4, this is 4, this is 4. So it's a 4 by 4 little square, which its area is 16. Look at that, it's that 16 again. 16 goes right there. Now, when you're actually completing the square, you don't always draw this picture like I've done right here. Usually what you do is just do this kind of business. You go, I take half of this 8 and make that a 4, so I take half of that. And then you square that and you get the 16, right? That's exactly what happened. We used to have an 8x here. We split that rectangle in half, put 1/2 up top and 1/2 on the right-hand side. And then in order to get the side length of the square, it's just that half length, and we square it and you get the 16. Okay, well, there you go. Well, again, 16 is not the answer. What 16 is equal to is a plus 1.5. And look, that's the exact same thing that came from the discriminant version of this thing. That these two guys are exactly equal to each other. And when I set them equal to each other, subtract the 1.5, I get my 14.5. So there you have it. 3 distinct methods to find the one distinct real solution.